Okay. Good to have you all on this call. Good evening once again. It's another time to learn. We have a facilitator on the call. So without wasting much of our time, let's just go straight into it. So Mr. Edward, please, can you confirm you can hear me?
Yeah. Yes, I can hear you.
Okay, great. Okay,
Yeah. Good
you have the
evening.
floor, sir.
All right. Yeah. Good evening, everyone. We're welcome once again to the session, and I guess today is going to be the last session, and it's going to be interesting as before, as usual, and it's going to be impactful. So we're going to go straight into some things I have for us today, which we'll be doing, and this part is a bit, it's going to be a bit technical, and it is bringing insights. It's a method of generating insight from data using a machine learning approach or machine learning say features. So I'm going to, okay, please, I'll share my screen. Okay. Please confirm you can see my screen.
Yes, we can see it.
Okay, fine.
Yes, you can see your screen.
Okay. So today we'll be making use of a data. The data we'll make use of is a data that was once hosted on Kaggle, the Kaggle computation data. I'm going to share the link. So it's a data that is related to heart disease indicator. So a survey was conducted in 2020 around from over 400,000 respondents, and they created variables, over 200 variables to identify heart heart disease indicator. So a lot of variables will speak, and we'll be creating a visualization around it. Though we can also create a machine learning model around it to get insights from it. But we'll be working around the data visualization and visualizing that data. And I'm going to give a background about the data. So like I said, the data is just a survey data collected to get the what are the key indicators for heart diseases, and it is most of the time, let me say most of the time, we are most of the time variable driven. Variable driven means that when you're building a machine learning model, I'm sorry for digressing into machine learning. So when you're building a machine learning model, you do something called feature importance to understand that, okay, this is the best variable, or these are the best feature that can explain my model. But in this case, we are going a bit advanced and a bit insightful, something more interesting. So I've shared the link to the data, and I have the data loaded. I think we are all familiar with how we can load data from our file into how we can load data from our file. Let me see. Where did I keep this? Okay. Okay, yeah, so it's something, so that's the file. So we just need to call the filing. It's a clean data, and it has, so the major variable is heart disease question. You have a heart disease or no? There are other questions around the BMI, the smoking. Do you smoke? Do you take alcohol? Have you ever experienced stroke, physical health rating, mental health, and lots of variables, so that will be used for to generate insights. Okay, let me give another background to the approach we'll be using. And the background is that there's a feature that we call weight of evidence. So please, if you've heard of that, if you heard of that before, please can you just say hi? Have you heard of what they call weight of evidence before? So you can unmute. Just say, okay, hi, I've had weight of evidence before. Yeah, okay. So weight of evidence is it's a computation that is being carried on during machine learning, and it's a way of extracting the 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 weight of individual response. So most of the time when you're doing machine learning, you get feature importance from the entire variable. But in a situation of weight of evidence, you get the importance at value level, starting from either by gender. So when you go to gender, you check, does male contribute more to explaining our target variable than female? So it goes into more granular details when you're making use of weight of evidence. I'm going to share a link that we can, if you would like to read, probably check have some further information. It's very interesting. I can tell you, it's very interesting, and it has always helped me in the industry to build one of the best model, because when you build model with your weight of evidence, it's most of the time stand out. So, but today we'll be doing some competition around the weight of evidence. So I've shared the link so you can read up on what they call the weight of evidence. So the word like the background I also continue the background that was given, that it's going to give you what is the corresponding weight, what is the corresponding value each response in a variable is adding to the bottom line. So at that point now, without doing machine learning, you can make actionable inference. Stakeholders can make actionable inference like a data scientist. This week I was building a model for one of my stakeholder, and I told her, I said, okay, this variable has the highest importance in the variable amidst the list of variable we are using. The next question is she asked me was that, yeah, sorry for the background noise. Hello, please, can you hear me? Hello?
Yes, yes,
Yes, we can hear you.
Okay, so she now said, okay, out of this variable, which of these variable are important? For instance, now, like if you say that, oh, if I should come and tell you that, okay, the general health is one of the significant variable, it does not end there. As a data scientist, as a data visualization expert, so I think with visualizing weight of evidence should be the first time I'm seeing it, but I can tell you, by the time we bring everything together, we are going to see a lot of insights. General health is not sufficient. We can't just say, okay, general health is important, or probably we can visualize the distribution. But can we know which of these has the highest contribution to the health status, or probably if the health of a particular respondent is healthy or not? So that's what we'll be working around. Please, like the link I shared, you can just read up. So we're going to be doing some computations using DAX to compute some of the parameters we'll be needing. I will be creating some extra measures to get this thing done. So because I've loaded this and I don't think I'll be transforming anything, so I'll just click cancel, and I have my data loaded already. So, but like a regular data analyst would do, is that starting with something simple. So I would want every one of us to replicate this, please. It's simple. It's a simple statistic. But before that, okay, let's go on. We want to visualize the key indicator for heart disease, and like we get to understand that the total number of responses that we have is like 22,000. So how do we get this? So I'm just going to repeat this again. I'm just going to recreate this so that we can just I like this. Please, somebody is not on mute. Okay. Okay. So the first thing is that we need to get a count. So what's the total number of observation? And let's check the distribution. So we check, okay, we use our card pan to bring in the numbers, and we can just drag in our heart disease and come back here and say, okay, just give us the count of all the record there. So, okay. So we have the total count. So fine. So we're bringing this here. So just want to recreate what's the first slide we have. And the next thing we need to do is that I would like to see on a card too, how many record do I have for yes? How many of this is yes and how many of this is no? So in this case now we're going to create a new measure to extract count for yes. So there are two ways we can do it. So for instance, if we should duplicate this, we can either create a measure to filter to count. So it's either we create a measure to filter out those customers that experience art-related issues, or we can also layer our filter on it. We can layer the filter on it directly, and to layer our filter on it, we come to this point. You see, filter on visuals, and we can add disease as a filter, and we click yes. So yeah, fine. So we've layered our filter on it. So, but we are not going to be using that, but we are going to be using the other way around. So these are other ways you can add filter, and in a way that when the filter is only specific to a particular visualization or probably a particular measure. So these are also a quick win to do it. And what we just need to do here is that let's rename this into, say, total total response. Okay, and in this case we change this to, so these are guys that so we call it let's call it heart event. So that is guys that had heart related issues, diseases, or anything they had problem with their heart. And we call this guy
Please kindly confirm.
Please, somebody's talking. Hello?
Oh, we are with you, Mr. Edward.
Okay. Okay, fine. So cool. So we are able to get that. So fine. So please, I want us to also at least replicate this, because we'll be going from basic to a bit advanced now. So so getting this done, most of the time when you're visualizing, it's always good to make it clear, and make it precise. So in this case now, I want to visualize customers that, for instance, I want to visualize customers that do not smoke, because there's one of the variables that we have is that some customers that do not smoke. So I want to see the distribution of customers that do not smoke and against customers that smoke for both the case of heart disease and the case of non-heart disease. If I want to go in a very simple and direct approach, picking my bar chart, I can say, okay, picking my heart disease, because that's going to be our axis against. So we can still bring this here, but as a value now we are counting. So yes, in this case now we understand that it's a rare event. A respondent that has issues with their heart, it's a rare event because it's just around 27,000 out of over 300,000. So it's very little, but in this case, I want us to do it in a case whereby let's check. We are going to create a measure that is just going to give us this value. So we are going to use that measure to now create the plot. So we're going to create two measures, one measure for the heart event and another measure for the non-heart event. So the non-heart event is that when the customer does not experience, the respondent does not experience heart-related issue. So to create that measure, like we can do a very quick measure, and to do that quick measure can just, so far we just need a filter. So we can just come here and we say, okay, I want to filter value, and it's going to ask you what's the base value you want to filter, and we can say I want to filter count, like count how many customer do we have in the entire the entire sample size, and I want to filter still by the same heart disease, and give me guys that that has. Okay, so no, let's pick yes first. So then I can just click OK. So automatically it's going to generate a measure for me, a quick measure for me. So this is the measure here, and so we can see the corresponding DAX functions query that generated that, and we can modify this. So most of the time you don't need to cram a lot of things, you just need to understand how you get it done. So so in this case I've created it before, but I'm going to create another one for this class, and so we can call it this is yes, so we call it okay, count of at event, so we're cool, we're fine. So that's fine. And we're going to create another measure. So I'll just copy this and recreate another measure, same measure. Just going to create a new measure and just paste it so that I'm not going to waste most of our time. Count at event, and this will be the non-heart. Okay. Non-heart event, and this guy will be low, so that's fine. So we're good to go. So what we have here is same as the measure we create here is same as what we have on this filter. So you see we have our 27K for our heart event, and when we also check on the other part, that's the non-heart event. So we still have our 292K, and so I prefer the measure, but you have a simpler way of getting this done. So because we're going to make use of that measure a lot of time now. So we're going to check the distribution. Let's check the distribution, and there's something I saw that's very interesting when I was visualizing this, and we're going to get there very soon. So let's pick a bar chart, and let's visualize guys that smoke, and let's see guys that smoke. Where's smoking? Okay, smoking. Yeah, smoking is going to be our axis, and our measure, our new measure. So that is guys with heart-related issues is going to be our measure. So now, see, this is now making sense. We can easily pick inference from this than when we have comparing the entire sample size, like what we have earlier. So if you are a developer, you learn how to copy and paste very well. So in this case now, we'll just remove this, and customers without art-related issue, you're adding that as values, and you're making sense, right? You're making sense. So that's cool. So we are getting to know that smoking. So the objective of this project is to identify what are the key indicators. So at a glance, so anytime you're given a visualization project, the first thing is that you must be able to answer your objective. So we're going to compare against if we make use of the if we are viewing from the entire sample size, and we're going to compare, and I want somebody to judge that which one is more informative. Okay, fine. Okay, fine. So I want somebody to judge this visual. So if we have just say, okay, let's just find a distribution of respondents with heart-related diseases and breaking it down to a more clear form like this. So that's the first one we did. Which one is more insightful? Though you might, okay, please, I want an open judge. So I don't want to be the judge of my own case. Okay, so okay, wait, this should be smoking. This should be smoking. This should be smoking. Okay, fine. Okay. So I want a judge, somebody to.
The first one is okay.
Why?
Because it tells us more about those people that have non-arts and the one that have art issue by smoking.
Okay, but the second also shows us those guys that had. Okay, yeah, yes. So because the second one is not showing us, because it only showed us general counts, it's not showing us, it's not doing a deep dive. So what if we should add a legend? So I don't want to agree with you, so let's argue it. So what if you should add a legend of, if we should add a legend to this, is it going to make sense? Do you think it's going to make sense?
Yes, it makes a little sense, but it makes a little sense, but just like maybe to save time or to save space, it makes a little sense. At least that legend helps to indicate different something. But in order for us to read the value, we still need to like click on the yellow or the blue part before you can now get your answer. But at a glance here, you can just get the quick results from this side, from the first one.
Yeah, thank you very much. So there's something, when you are doing visualization, there's something of relating to the size of the visuals. So we are going to get deceived by size. We are not going to be able to pick a lot of inference due to the size of the customer or the respondent without art-related issues. So would have our eyes will judge or probably would think it is insignificant to analyze, or will not be able to measure the difference between guys that are smoking and not smoking of respondent that has art-related issues. So that's why it is always good to do it to slice it down or break it down into something more clearer. So thank you for your contribution once again. So so we've done that, and with this now, we can easily see that respondents with heart-related issue, most of them smoke. Because respondents without heart-related issues, most of them don't smoke. So we can easily see a clear demarcation. So at a glance, we might not, okay, we might not be able to see that with our first chart. We might see it, okay, because this is smaller, this is bigger. But we can see it in a more clear terms um, with our chart broken down into um, two different parts. So we can create lots more visuals with this, and it's going to make sense. So if we continue, we can have something like this, something around this. So this is, yes, guys that smokes, and we can also check around their age distribution and see how is their age distribution affected, and also bringing what they call our race as bringing our race as a filter. So there's something interesting I saw when working with the race. So the race is saying that, okay, guys that smoke, okay, guys that had heart related. So okay, I'm coming. Okay, so guys that had heart related issue, most of them smoke. So, but let me see. I think so. When I went to Asia, I discovered that guys that smoke in Asia, not most of, not all of, most of them don't have heart-related issue. So it's good to also, so that's the reason why you add filter. So when you see the general view, most of the time we get deceived by the general view and say, okay, he's saying this, but when we go a bit down, so that is where this guy is coming from, the weight of evidence. Because weight of evidence, so when you drill down, weight of evidence don't just give you artificial level, it's going to give you drilling down into options, into inner labels, and we're going to see that in a bit now. So the function of weight of to make use of our weight of evidence, we need something. I'm going to drag something to my screen. Okay, please, can you see my screen? Can you see the weight of evidence page?
Yeah. Yes, I can see it.
Okay. So the weight of evidence of every option is computed like this. So we are going to convert this to that function, and we're going to also get this out. So this is, for instance, a feature X and having label A to E. So we are going to, for instance, if you are picking gender, having male or female, number of events. So number of events means how many of this male, how many of this level has experienced art related issues, and how many of them did not have. And we do some computation, and we do computation for the percentage of event and the percentage of non-events, and we get the weight of evidence. And afterward, we can get what we call the information value. So the information value is what is used at the back end for ranking feature importance. So, but in today's class, we're just going to stop at the weight of evidence. So at the end of the day, we're going to see the beauty of what they call the weight of evidence. And if you are doing any visualization, if you're able to give out the weight of evidence, it's going to give out a lot of insights. Without doing machine learning, any layman will be able to make sense on how important each response is to the entire or to the entire to the grand objective. So for those of us that have opened this, so we're just going to compute this. So the first thing that is needed to be done is to create. So we've created our measure. So I'm just going to create this a blank page now, and so I'm going to create that same table, and we've created our measure. So let's pick the first time I picked, okay, let's pick general health. So general health. So we want to compute the weight of evidence of general health. So from our measure that we used, so we have our measures count of art events. So we drag it in, and that's going to give us count of customers with events. So customers who had related issue, and we can also drag our second variable, customers without art. Like that is non-art event. So that's making sense. So at least we've gotten 2 columns out of our column. So you can see the beauty of making use of creating extra measure. So in Power BI. So there are a lot of you can do read up on writing a more complex DAX function. So and the next thing is that I want to compute the percentage of events. So the percentage of events in this case is that, so we'll be needing something around 150, 1,500 divided by 27,000, 7,000 divided by 84,000. So in that case, now we can create a new measure. So I created a measure for it, and I called it percentage of events. So the percentage of events is a function of, say, okay, um, it's just so let's see. Okay, no, let me create a new measure so that we're not going to discuss the flow. Okay, we're going to create a new measure, and the name of the measure is percentage of events. So we just going to call this guy percent of events. So and the percentage of events is going to be the number of events. So that is the first measure we created. So and we can call in a measure in a measure. So that's one interesting thing about that. So count of heart events divided by 27373, and that gives us, so what's that give us the percentage of events, and we are going to create another measure, and we're going to call that percentage of percentage of okay of non-events. So and that will also be our new measure, count of non-events. Yeah, so we are dividing that by 292422. That's 2,000, and so we're good to go. So having created the two measure, we can bring them in. So we are creating that table. So that's making sense. So we're good to go. And the last thing is just for us to create our weight of evidence. And the formula for our weight of evidence, as seen in the slide that was shown, is that is that's taking the natural log of percentage of events divided by percentage of non-events. So creating a new measure, and we call it rate of evidence. Because I've created one before. So you can take the natural log, just type your ln, and call percentage of events divided by percentage of non-events, and we'll be good to go. So automatically we've generated a weight of evidence, and we can also call that in. Okay. So calling this in would make sense. So this is now making sense, but there's a place we are going. We don't in visualizing this, might not need the rest, but we need the weight of evidence. So in this case now we're not going to make use of our weight of evidence, and to make use of our weight of evidence, I'm going to show us how we do make use of weight of evidence, and I will ask somebody to please explain that to us. For instance, now let's pick another variable. I don't want to use general health condition. Okay, let's pick physical activity as our and let's pick our weight of evidence. Okay. Yeah. So this is making sense now. So what this is telling us is that if you don't engage in physical activity, you have higher propensity of having heart-related issues. Okay. We are going to compare this to another. So we are going to do some comparative so that we can see the beauty of when you are plotting using what we call the weight of evidence. So let's plot our general. Let's have a general plot so that we can compare. Up. So our values by physical activity. Physical activity. Okay. Can somebody tell? Okay. So now let me explain this. Common if we go with our regular bar charts, our regular bar in the case of 2 levels, because very soon we are going to work with multiple levels and which might not be glaring. In the case of 2 levels, where we can see that okay, we have yes and no, but we don't know how these yes and no are contributing to the bottom line. So this just counts. We discover that okay, male and female, and let's say they engage in physical activity, yes or no, and the highest thing we can do is add legend of heart disease, and like what we did the other time. So this is the highest thing we can do. So we can't know how, we can't know the effects or which variable, which option has the highest effect. By frequency, we can be seeing count, but we might not be measuring the effect. But at a glance, when you make use of weight of evidence, you can speak as a machine learning expert even while visualizing. So with this now, we can see that there's a significant effect. See, another thing that is close to what we are doing is that when you're trying to compute in a situation of on a 2-level variable, you compute what they call the t-test, and if it is multiple level, you compute what they call, say, do the analysis of variance. Instead of using a complex inferential statistics in quotes, you can also do a very simplified descriptive statistics in visualizing, in giving the best inference. In this case now, we don't need a magic to tell us that I want to add label so that we can see the value. I don't need anybody to tell me that when you don't engage in physical activity, you have higher propensity of having health-related issues. You can imagine guys that don't do physical activity, they have a weight of 0.45, and guys that engage has a weight of minus 0. So if you engage in physical activity, it's telling you that you will be far from experiencing what they call heart-related issues. That is the beauty. So you can see clearly. So you don't, in this case, maybe in case of model building, but when you are explaining to stakeholders they can make informed decision. And I can tell you most of the time, I get back to these questions. When I build models, they come and ask me, stakeholders don't understand your Python script. They don't understand a lot of things. They don't understand your feature engineering. They don't understand the accuracy. They want to know which variable is important. And out of those important variables, which level is more significant. So with this now, we can clearly see that the more you engage in physical activity, the farther you are from any art-related issue. You can say how far it is. And when you don't engage, you can say how close you can be to having art-related issues. So in same measure, we created more slides, and we have this. So we continued by saying, let's check the effects of the weight of evidence on what we call on our race. So you can see that the Americans, they have art-related issues, but the Asians, if you're an American, you have higher chance of having heart-related disease than an Asian. So an Asian, maybe if we go do a further deeper dive, we will see that maybe most of those Asians, they engage in sport activity than the Americans. So those are other deep dives. So when you're doing analytics now, more question comes. So when those question comes, that's when you begin to ask the question, why? So if I'm to do this for a stakeholder, I know I would like to go further to ask, why is the Asian having low or having better heart, or probably, or let's say having less heart related diseases? So we can now say, okay, should we check it against their gender, or against if they take exercise or the likes? And another variable we consider is diabetics. So if any respondent is diabetic, so a diabetic patient has higher propensity of having heart-related issue. In this case now, I don't need to be a doctor before I can prescribe. I can tell you, oh, are you diabetic? Oh, if you say yes, oh wow, you're gonna have health issue. And if during pregnancy, if you're diabetic, that doesn't mean you're gonna have heart-related issue. So those are the inferences. And also, talking about kidney, most people with kidney disease have heart-related disease, and female has less heart-related issue. Please, any question? We have 5 more minutes. Any question on weight of
So far,
evidence?
it's clear. By me, I don't know of others. So by me, I understood it very much well.
Okay, so that's fine. In summary, I want to tell us something about visualization. I believe in more analytics in visualization, not reporting. We can do a lot of reporting, like what we did here. What we did here can be some reporting, but analytics is bringing out insights, bringing out insights from data. And the more you master the art of bringing analytics into your visualization, the more attractive, the more useful your visualization will be. If it's just reporting, there are many people know much about reporting, but when it comes to analytics, and that is going extra mile to get some computations done. So that's why I will advise you can go can just take up. I think there are a lot of materials that has been shared in the class group on mastering DAX functions and learning a lot about it. Please and please do well to always read them and practice make perfection. And I will recommend that on LinkedIn I saw there's a group there's a company that hosts weekly visualization challenge. So you can see maybe I'm going to share the link on the class group, and I'm going to share the list of visualization other people have done, so that because when you see a lot of visualization, you can also train your mind. You know, our mind is wired in a way to learn. So maybe when you see a lot of patterns, how people do their visualization, you train your mind to also have the ability to generate such or replicate this kind of visualization. And I also advise that you engage in competitions that can aid the visualization, that can skill and sharpens it and make it better. So so that is that. So in case, so in the absence of question, I think I'm going to hand over back to Babatunde.
No, sir, before you hand over, I just want to ask if this data will be available for us at least as you have done it now. Maybe individual can later also practice it, maybe tonight or by tomorrow morning, at least when we are just doing it over and over, we know this type of what's it called, weight of evidence more. Thank you.
Okay, yes, I shared the link to the data. So the data is on Cargo, it's a Cargo data. So I shared the link already, so you can just go there and download the data.
All right, sir. Thank you so much, sir.
You're welcome. Okay, over to you, Babatunde. Hello, Babatunde. Hello?
I'm not sure he's on the call.
Okay, no problem. So thank you everyone for your time. Thank you for coming around. Thank you. Do enjoy the rest of the evening.
Thank you so much.
Thank you.